Hey class, today's essential question is how are mechanical and chemical weathering related? The objective is to compare and contrast mechanical and chemical weathering. Take some time to copy this diagram into your input section. You're more than welcome to pause it just so you can get all of this information down. Once you're done, feel free to unpause so you can move on. So let's remember from our soil formation notes, what is weathering? So weathering is when an object wears away or changes its appearance by long exposure to the air. So there are two types of weathering, which we'll learn about today: mechanical, which is also known as physical, or chemical weathering. So let's start learning what mechanical or physical weathering is. This is when a rock breaks down into smaller and smaller pieces, but it doesn't change its chemical composition. It occurs for three reasons: frost wedging, unloading and exfoliation, and biological activity. Frost wedging is when water can get into the cracks of rock. So when water freezes, it expands, and this expansion causes the rocks to break apart. So this diagram at the bottom of the screen shows exactly what I just described. So there's water that's filled into this crack in a rock. It freezes and expands, and then it causes the rock to break. Next, unloading and exfoliation. So this is another cause of mechanical or physical weathering. This is when rocks form underneath the ground and they form a lot of pressure. And so this pressure then gets released and the rocks will expand and are brought up to the surface. And lastly, the last example of mechanical or physical weathering is biological activity. So this is when living organisms break apart rocks into smaller pieces. So as you can see in this diagram, the roots of a tree trunk have grown into the rocks and broken them apart. So now that we know what mechanical or physical weathering is, we're going to learn about chemical weathering. So chemical weathering changes the chemical composition of rocks. It turns it into a new compound. So this happens when water mixes with minerals. So an important distinction to notice is that chemical weathering changes your composition, whereas mechanical or physical weathering does not change your composition. So key differences between mechanical and chemical weathering. During mechanical weathering, the chemical composition of a rock does not change. Each piece has the same chemical composition or characteristics of the original rock, whereas during chemical weathering, the rock is transformed into one or more compounds. So let's do a check for understanding. We're going to label each of these 8 questions as either mechanical or chemical weathering. The mineral iron rusting inside a rock. This is mechanical or chemical? If you said chemical, you are correct. A rock cracking after a big ice storm. Mechanical or chemical? Mechanical. This is an example of frost wedging. A limestone rock developing holes from rainwater. This is actually chemical. So rainwater is naturally acidic, so it actually will mix with the limestone, the minerals, and then that will be chemical weathering. Blowing sand at a back wearing down on a wooden bench. This is an example of mechanical weathering. Tree roots cracking a sidewalk. Mechanical weathering. So this is an example of just biological activity. An iron nail that has been left outside rusting. This is an example of chemical weathering. Salt or halite in a rock being dissolved by water. This is also an example of chemical weathering. And then lastly, acid precipitation. This is also an example of chemical weathering. So now that we've done our check for understanding, we're going to go through a few more examples categorizing mechanical or chemical weathering. So this Chinese statue was built in 618 AD. Over the years, the face of the statue has been weathered by acid rain, which has dissolved parts of the statue and given the Buddha a blackened nose. Mechanical or chemical? This is chemical weathering. Great job. This arch of rock in the Grand Canyon is made from sedimentary rock that has been worn away by the wind blowing on it for thousands of years. Is this mechanical or chemical? Mechanical. Great. This rock might look foliated, but those are not foliation lines. The cracks in this rock are caused from where water entered the rock and froze, cracking the rock apart into pieces. Mechanical or chemical? This is mechanical. This is frost wedging. There's iron inside this rock. When iron is left outside and exposed to rain and oxygen, it will often rust like this rock did. This is chemical weathering, so the composition of the rock is changing. This gravestone is made out of sedimentary rock limestone. Over 200 years, the animal on top of this rock has been dissolved away by rain. Mechanical or chemical? Chemical. And then this is a 400-year-old bonsai tree. This tree's roots and trunk have pushed through the rock on top of it and cracked the rock into pieces. So this is what? So if you said mechanical weathering, you are correct. This is just another example of biological activity. The roots pushed through the rock and they broke it into pieces. So lastly, what factors impact weathering? There are 4 factors. Mechanical weathering speeds up chemical weathering. So if there's already been mechanical weathering there and then chemical weathering comes in, it will also increase the rate of weathering. And then rocks chemical composition to begin with. Certain chemical compositions can either increase your rate of chemical weathering or decrease your rate of chemical weathering. Temperature and moisture. So with more temperature and more moisture, you will actually have an increase in weathering compared to when there is a lower temperature and less moisture. And then climate, how many times water will freeze then thaw, so that changes how many times you'll see frost wedging occur. So that will also impact weathering. So copy this chart into your output. You'll need to copy down these 4 things on the left-hand side. So the rate of mechanical weathering can impact the rate of chemical weathering. So how it works is when rocks break into smaller pieces, mechanical weathering accelerates chemical weathering by increasing the surface area of the exposed rock. And then a rock's mineral composition can dramatically affect the rate of chemical weathering. How it works is rocks that are made up of minerals that are soft, they can erode faster than other rocks. And then climate can impact the rate of weathering. So climatic factors control the frequency of freeze-thaw cycles, which can then affect the amount of frost wedging. And the contrast can also occur with temperature and moisture. So the more vegetation that is present in an area, the less likely it is for soil to erode because roots help hold soil in place. So once you've copied this output down, make sure that you complete your guided your independent practice and your exit ticket for the day. Thanks guys, have a nice day.